Hello. In this video, we're going to go through 332, which is to, oh goodness, that's the wrong learning target. It's really to interpret real-world polynomials, still by evaluating, but not using the factors. So what we are doing is we have our polynomial here, and we are just going to interpret certain points of that polynomial, depending on if we are looking for x or f of x. And so our x is our input. Doesn't always have to be x, but this is our like independent variable. And it's often, but not always, but it's often time or number of units. Those are typically what your input represents, time or number of units. And then your f function is your output, which is your dependent. And that can really be anything. It's just like whatever you're looking for, whatever you're trying to talk about. So this is like what the equation represents. Think of it as like what the equation represents overall. So now these are all going to be story problems, and you're going to be asked to find and evaluate certain points and then interpret them with the context. So I'm just going to read this story out loud, and then we'll talk about what this means. So it says cardiac output is the amount of blood pumped through the heart. The output is measured by a technique called dye dilution. For a patient, the dye dilution can be modeled by the function, and then it gives you our equation here, where t represents time in seconds after injection, and f of t represents the concentration of dye in milligrams per liter. Evaluate f of t for t equals 4 and t equals 17 and describe what they mean. So first of all, there's just a small typo. These x's should be t's, so if you just want to quickly change those, that would be great. And then I always want to underline what things represent. So it says t represents time in seconds, and f of t represents the concentration of dye in milligrams per liter. So like those are the two things that we're talking about. And it asks us to evaluate f of t for two different t values, 4 and 17. So I'm going to make a little column. This is for t equals 4, and this is for t equals 17. And t are those time values. So I'm just going to put right here that this is in seconds, just so at the end I don't forget. So now I'm going to plug in my value in for t. So I'm going to use my calculator, and I'm going to just plug that whole thing in. Be careful with your decimals since these are all decimals. Make sure you do the correct number of zeros. All right, and we get 3.839 and so on. If it's ever a decimal answer, you can just round to 2 decimal places. So 3.84 is perfect. And now I'm going to do the same thing for 17. I want you to try to type that one in as well. So pause this video, try to type it in, and push play when you're ready to check. All right, you should get 1.64. What's happening here? It does not look like that. 1.64. There we go. And so that's our answer for 17. Now, we need to describe what these values represent in terms of this function. So I'm going to write a sentence, and I'm going to write one sentence to include both, but you could also write 2 separate sentences. That's fine. We want to interpret, and I already know that these values up here represent seconds. So I'm going to start my sentence with after 4 seconds. And then I need to figure out what this means. And this is our f of t, so when you plug it in, what you get. and F of t represents the concentration of dye in milligrams per liter. So after 4 seconds, the concentration of dye is 3.84 milligrams per liter. And after 17 seconds, it's at 1.64 milligrams per liter. And so you are going to incorporate both what you plugged in, the input and the output, and make sure you use correct units. And you can also make some sort of a conclusion. So I could also ask you over time, is the concentration getting stronger or weaker? And you should be able to say that it's getting weaker because we went from 3.84 to 1.64. And that's it.